We have three separate code bases. It's very convenient because it allows us to work separately on our own parts without being held back by one person not being able to do something. Now, this is a complete Sudoku. That's our mobile app. This is a test for the gameplay, and this is a test for the OpenCV capabilities. So, first things first, this is our Android app, and eventually all our code will be integrated into this one here. Now let's test it out. Okay, now it's running, so you can log in. You also have the ability to register for an account, of course. And once you're logged in, you can play a game of Sudoku. But of course, you don't have to have an account to play. And here is our app's backend. See, we can have our users here, other information. Next up is a Java desktop application that implements our gameplay. It's not for Android Studio, but the underlying classes are the same, and they're actually loosely coupled with the interface. And actually, this uses JavaFX, which uses FXML files just like Android Studio, so migrating shouldn't be too difficult. Now, this is what a play is like. So, here's our gameplay screen. You can click a number, click there. There's two styles of inputs. You can click on the grid first or the number first. You can highlight particular squares. You can even highlight like all 8s. You also have the option of putting in smaller numbers. So you know like that's a 3 or that's a 3, for example. You can of course delete your inputs. You can also get a new game at any time. You can generate those. You can load an old saved game. You can save your current one. All very nice. And of course, you can solve it. And finally, we have our Visual Studio OpenCV environment. This will be used for our image capture for Sudoku. Here's what we have so far. We actually made some pretty good progress. So, first things first, we load the Sudoku image. Then we create an empty box of the same size. Then we blur the image so that we can smooth out the noise. Then we threshold it so that there's only 2 shades. Very convenient. Now we reverse the colors. Now we dilate them so that the grid is all in one shape. We don't want any breakpoints. Now, next we find the largest blob, and it's interesting because this is done by using the tool fill and seeing what was the largest thing that was filled, which is obviously going to be the grid. We get rid of everything else. Now I have the grid. We narrow it down a little, which is for the next step where we show the lines through the grid. Now we merge some of them, and we can find the edges, roughly. Put that in the original image, and resize it. And this is our grid. And then we do the same step here. And we read the digits. As you can see, they're not that accurate, so this part still needs a little work.